Good morning. I'm Tabitha Thompson with NASA's Office of Communications. We're at NASA's Wallops Flight Facility in Virginia today. NASA commercial cargo provider Orbital ATK is scheduled to launch its 8th mission to the International Space Station at 7:37 a.m. Eastern Standard Time, Saturday, November 11th, from Wallops. Live coverage will start at 7 o'clock on NASA television and the agency's website, which is nasa.gov/live. Here to discuss the status of launch operations as well as the research investigations headed to the station are Dan Hartman with the International Space Station Program at NASA's Johnson Space Center, Frank DeMauro, Vice President and General Manager of Advanced Programs Division at Orbital ATK, Kurt Eberly, Antares Deputy Program Manager at Orbital ATK, Camille Elaine, with the International Space Station Program's Science Office, also at Johnson Space Center, and finally, John Dickerson, who is Test Director at Wallops Flight Facility. We'll begin with Dan.
Thank you, Tabitha, and good morning, everybody. It is great to be back at Wallops Island for the 8th Orbital ATK mission. We are looking forward to a very exciting morning tomorrow. We have Cygnus completely packed full of cargo on this mission, 7,400 pounds of cargo. About 1,900 pounds of that is in the research realm. Presently, we have 3 active mid-deck lockers receiving power off of Cygnus as of right now in support of our principal investigators. And Camille will talk a lot more about the research that we plan to conduct with the cargo going up on this mission. With the launch tomorrow, Cygnus is planned to arrive on the station on Monday morning. Station systems are fully operational. We have a few more checkouts to do with crew training before we actually capture Cygnus. Paolo will be the prime operator of the SSRMS. He'll capture Cygnus Monday morning, and then we'll bring Cygnus into Node 1 Nadir berthing port, and that will all be done via ground control operations. Hatches will be open the following day, and then they'll be able to start unloading all the cargo immediately. With our crew of 4, we plan to get the cargo off of Cygnus very quickly. And then for the first time, we plan to relocate one of our payloads that is presently operating on board the International Space Station into Cygnus and actually do what we call kind of extended laboratory operations inside the Cygnus module. And that'll be our first time we've done that. That's really trying to give us some more flexibility of how we operate our payloads. Sometimes our payload facilities inside the modules are oversubscribed, and then having this capability with inside Cygnus offers us a tremendous amount of flexibility. The present mission duration will be through December 3rd, and when we leave on December 3rd, we anticipate we will have completely packed Cygnus full of disposable cargo, and I can't emphasize that enough. We have a crew of 4 up there on the USOS side, crew of 6 in total. We do generate a lot of trash, be it food or some foam that our ORUs fly in. Removing that trash offers our teams a tremendous amount of flexibility on how they operate. The crew members operate on board the International Space Station. So we always look forward to a Cygnus vehicle coming to the ISS. We can dispose of all that cargo. The crew loves it, and then we're on our way for much more flexible operations. So Cygnus just offers us a tremendous capability for that. Consumable-wise, we're also in great shape. This is actually our 5th CRS mission of the year, and we have food, water, and cargo supplies to last us right now through midsummer of next year. So again, great shape. If we look forward, again, I mentioned Cygnus will be released on December 4th, and that's going to be after we actually unberth it from the Node 1 Nadir on December 3rd. We plan to do some operations with Cygnus and maneuver it and hover it above Node 1 Zenith, or Node 2 Zenith, and we plan to do some GPS checkouts at that location, and that'll give us a better characterization of our GPS system for when commercial crew vehicles start flying and they have their vehicles mounted at that location or docked at that location. And we just want to get a little bit more characterization of our ISS GPS performance during that operation. So again, that will have us release Cygnus on December 4th. Also on December 4th, we plan to launch the next SpaceX 13 out of KSC. And so we'll have a release and we'll have a berthing a launch on the same day. So we're looking forward to that. SpaceX would then berth on December 6th. 51S with Randy, Paolo, and Sergey plan to return on December 14th. And then we have a pretty quick turnaround for the next crew coming back up the station to get us back up to a crew of 6. That launch will be on December 17th. Later on in January, we have 2 EVAs planned. We'll have a lot more discussion on that as that gets closer. We've had the SSRMS has 2 latching end effectors on either end. We changed out one of the end effectors in a series of EVAs in October. We plan to get the other end effector in late January. And I just want to give the Canadian Space Agency a lot of kudos for the operations of the SSRMS. That thing has been in operation for nearly 15 years, and so it's kind of ready for a change out on those components. But it went through all of the major assembly tasks to even build the International Space Station. So tremendous success on the arm, and we're looking to get the second of the latching end effectors replaced. So with that, the ISS is ready to go. I'm sure Frank and Kurt will talk a little bit more about where they stand as far as vehicle readiness, but I can tell you our crew on board is looking forward to the launch and anxious to get inside and get the cargo and the goodies out. So with that, turn it over to Frank.
Okay, thanks very much, Dan. It is great to be back here at Wallops, especially to be at this table with our partners on this mission. I do want to first, though, say happy birthday, 242nd birthday to the United States Marine Corps. So congratulations to everyone out there. I also want to say happy Veterans Day to all the veterans out there. We have the honor and privilege of working with many veterans, especially in our business. And they are special people, and we thank them very much for protecting our nation all these years. So we also would like to, we're excited to get Cygnus launched again off of our Antares rocket. We do want to thank our Antares launch vehicle provider and our brothers and sisters on the Antares program, our NASA customer, certainly the team here at NASA Wallops who continue to do a great job getting us ready for the launch, as well as the team from the Mid-Atlantic Regional Spaceport and Virginia Space for their support of the mission. So we're looking for a great mission tomorrow. We've got a lot of cargo to deliver, crew supplies, equipment, and of course those scientific experiments. So let's take a look at a video showing the processing of Cygnus as it's getting ready for launch. So here you can see the OA-8 service module. This is integrated and tested at our facility in Dulles, Virginia. That was shipped here by truck to Wallops. Here you can see our pressurized cargo module, which actually gets delivered directly from our supplier in Italy. And here, after we've loaded the initial load of cargo, we actually mate the 2 modules together, and that's when we actually have a Cygnus. We get the spacecraft ready for moving from the H100 facility to the V55 facility where it's fueled and the NanoRacks CubeSat deployers are installed, and then eventually we'll get moved over to the HIF where the spacecraft will get removed from the shipping container, rotated over to the horizontal position, and it'll get mated to the Antares launch vehicle. Once we're mated, we'll put in some final cargo load. On this mission, as Dan said, we're going to be launching about 7,400 pounds of cargo to the space station. Among that cargo is a student experiment sponsored by Orbital ATK in partnership with Higher Orbits, a nonprofit company based right here in the Commonwealth of Virginia. So that is very, very exciting for us to take part in. Here you can see the launch vehicle fairing getting moved to encapsulate the spacecraft. Of course, we say our temporary goodbyes to Cygnus because we're going to see it again once it approaches the station. Here you can see once we're about 10 minutes after launch, the spacecraft will separate and we'll begin the process of deploying the solar arrays, which are built by our facility out in Goleta, California. And then once we've done our orbit raising, we'll phase with the space station and we'll start the process of maneuvering the spacecraft underneath the space station for the rendezvous and eventual berthing. The spacecraft is controlled from our Mission Control Center in Dulles, Virginia. It's monitored extremely closely by our friends at NASA, the ISS Program Office and ISS Mission Control Center in Houston. They keep track of it every step of the way. And when we're about 10 meters below the ISS, the arm will come out and grapple us. And here you can see the arm maneuvering us where we are actually docked to the space station. Once that happens and the safety checks are completed, we'll open the hatch, or not we, but the crew will open the hatch. The crew will begin unloading the cargo and start refilling the module with trash, including and then we'll also take part in the Tango Lab experiment. Once we're done, we will get unberthed from the station, pulled away, released from the arm, and we'll begin the next part of the mission where we release CubeSats, several CubeSats from the NanoRacks CubeSat deployer on the outside of Cygnus. We have 14 flying this time, which is a record for Cygnus, and then we'll re-enter the atmosphere and complete the mission as we re-enter over the South Pacific. I would like to take this moment to express how proud we are to name this mission in honor of Gene Cernan. Mr. Cernan, a veteran of one Gemini mission and 2 Apollo missions, as well as being the last human to have his feet on the surface of the moon. He was truly a pioneer for America's space program, and he was actually one of the early supporters as Orbital Sciences Corporation came into existence. And so we are extremely proud and honored to be able to name the spacecraft the SS Gene Cernan. So we are excited for this mission. It's going to be a beautiful day tomorrow morning. I think the Antares team is ready. The Cygnus team is very ready. So we'll look forward to a great day. And with that, turn it over to Kurt.
Okay, thank you, Frank, and thanks to all of you for being here. On behalf of the Antares launch team, I'd like to say we're very excited to be back here at Wallops with our NASA and Virginia space partners. I'd like to recognize Dale Nash and the rest of the Mid-Atlantic Regional Spaceport team from Virginia Space, who operate and maintain Pad 08 for us. They've done a really outstanding job. I'd also like to recognize Bill Robel, John Dickerson, Jeff Reddish, and the rest of the Wallops Range team for the outstanding support we received from them in planning and preparing for these launches. So thank you all for helping us to get to this point. I recognize some familiar faces here. Many of you may have been here last fall for the OE5 mission. Just a word about that. That mission was the first flight of our, what we're calling the Antares 230 configuration, featuring RD-181 engines on the first stage. That flight was very successful. We took all the data that we collected in video from the launch, and we performed a very thorough data review. And we found no in-flight anomalies, which is great news. So it was a very clean mission, and we're really excited about the excellent flight performance of the Antares 230. And that's the same rocket we'll be flying tomorrow on the OE8 mission. A note about pre-launch processing. Our team down here, we have a permanent staff of about 35 folks. They worked really hard to get ready for this launch as early as August. And so since then, we've been maintaining readiness for whenever NASA needed us to launch. Cygnus came over to the HIF, as Frank said, on the 27th of October, followed by rotation and mate to Antares. Final cargo load was completed just earlier this week on the 7th, followed by fairing installation, and then we rolled out to the pad very early yesterday morning. So since then, we've attached to the pad, we've gone vertical, and just this morning we executed our major verification test we call the combined systems test, and that's basically where we turn on all the emitters from the rocket, and we verify all the interfaces between the rocket, the pad, and the range, and that's all complete and looked really good. There is one issue we're working on the pad. There's a misbehaving nitrogen regulator on the ground side that supplies nitrogen for some of our purge systems. That's being swapped out with the replacement unit. We expect that to finish this afternoon. For launch day, the Antares and Cygnus teams will arrive on console at the control centers. There's a couple control centers we use at 1 a.m., and then we will execute a 6-hour, 15-minute countdown, which will start at 1:22 a.m. Fuel loading will begin about 1.5 hours before launch. We'll be simultaneously loading liquid oxygen and kerosene into the stage 1 tanks. The engines are ignited at L-0 to an intermediate power level after an automated health check is performed on each engine. The engines are throttled up to full power, coincident with release of the hold-down mechanisms at the base of the rocket, and also retraction of the transporter erector launcher, which we still have attached as a umbilical mast. Liftoff will actually occur about 3.5 seconds after engine ignition when thrust exceeds mass. In terms of the launch sequence, as Frank mentioned, it's about 9 minutes total, a little over 9 minutes. We'll lift off and fly straight up for about 25 seconds, after which we'll pitch over and head down range in the southeasterly direction. Stage 1 will burn for about 3.5 minutes before main engine cutoff, or MECO, is commanded. After MECO, stage 1 is separated, and we enter a coast period for about 30 seconds, after which the payload fairing and the 1-2 interstage are separated. Stage 2 is then ignited and burns for about 2.5 minutes. After that, we're in orbit. Cygnus is separated. Our target orbit for this flight is about 190 by 290 kilometers. From there, Cygnus uses its very capable propulsion system to raise its altitude and adjust its phasing to rendezvous with the ISS. So anticipating questions you may have about the cold weather forecast for tonight, I can see everyone brought their coats, so you're semi-prepared. But I want to let you know that our air temperature constraint for Antares is 20 degrees Fahrenheit, so we don't anticipate any problems with being able to launch tomorrow due to the temperature. The rest of the weather forecast looks very favorable, with clear skies and moderate winds both at surface level and at altitude, which bodes well for the launch. In fact, the launch weather officer gave us less than 5% probability of violation this morning on his latest report, which is very good. All right, next I'd like to show a short video that walks through some of the processing steps for getting Antares ready for launch and which shows off some of our outstanding local staff here at Wallops. It also includes rollout and liftoff footage from prior missions as a preview of the launch tomorrow. Can we cue that video? Okay, thank you. Finally, I'd like to share some sad news with all of you that our former president and chief operating officer of the company, Mr. J.R. Thompson, Jr., passed away this week, just Tuesday evening, at the age of 81. Prior to joining Orbital in 1991, J.R. had a distinguished career at NASA, where he served as director of the Marshall Space Flight Center and as deputy administrator of NASA. During his time at NASA, J.R. helped the agency recover from the Challenger accident and get the shuttle back flying again. At Orbital ATK, JR was an inspiring leader for the company and for me personally, and he was a major contributor to the success of the company and its many aerospace projects. On the CRS project in particular, JR was a driving force behind the development of the Antares rocket, the Cygnus spacecraft, and Pad 0A here at Wallops. We couldn't have done it without him. So please join me in paying homage to this great leader. He was truly one of a kind and will be sorely missed. Thank you.
Thank you, Kurt. We'll now go to Camille Elaine with the International Space Station Program Science Office for an update on the investigations launching to the space station.
Thank you, Tabitha. Good morning. It's great to see a packed house here, and it's my pleasure to share with you some of the science that will be flying tomorrow on the Orbital ATK CRS-8. We're really excited to be launching, as Dan said, about 1,900 pounds of research supplies and science that will support almost 300 investigations that will be conducted during Expedition 53-54. These experiments span all the scientific disciplines that ISS supports, including human research, physical sciences, biology and biotechnology, technology demonstration, earth and space science, and education. We do this research on ISS for the purpose of advancing our scientific knowledge through discovery, for enabling future human space exploration through NASA-sponsored research, for fostering space commerce, a commercial marketplace in low Earth orbit, and also research that benefits improving the quality of our lives here on Earth, both sponsored through the ISS U.S. National Laboratory. Later today, we'll have the What's on Board briefing, where some of our principal investigators will have the opportunity to highlight in detail some of their exciting and groundbreaking research that includes the ECAMSAT, the E. coli antimicrobial satellite, which is a mission flying on a 6U nanosatellite deployed from the ISS GEM module, and will investigate the effects of microgravity on the antibiotic-resistant E. coli bacteria. The researchers hope to understand whether bacteria is more resistant to antibiotics in space and what controls that phenomenon. This could help them design effective countermeasures for protecting astronauts on deep space missions. But it also has an impact to public health issues here on Earth, since some strains of E. coli actually cause bladder infections or UTIs, urinary tract infections. This investigation is co-sponsored by NASA and the U.S. National Lab, specifically NASA Ames Research Center and Stanford University School of Medicine. Then we have two exciting technology demonstrations sponsored by NASA's Space Technology Mission Directorate that look to advance cube and small satellite technology as a viable platform for both science, for exploration, and commercial missions. The first is the integrated solar array and reflect array antenna, which is this new hybrid system, solar system and antenna that will demonstrate high bandwidth Ka-band CubeSat communication capability for space applications. This is about a 5-month mission that demonstrates about 100 megabit per second data rate, up from about 9.6 kilobits per second that they get now, and elevates the antenna technology from a technology readiness level of 5 to possibly a technology readiness level of 7. Then there's the optical communication and sensor demonstration. That will be the first demonstration of space-to-ground laser communication with CUBE satellites. It will also demonstrate small satellite proximity operations, laser ranging and tracking, and propulsion. This mission is advancing the use of these CUBE satellite technology for optical communication and for relative position measurements between two satellites. Both of these capabilities have not been previously demonstrated, so groundbreaking research. And then we have a suite of education experiments designed by students from across the country as part of the Go for Launch Higher Orbits program and the Magnitude IO program, both sponsored through the National Lab managed by CASIS. The students' investigations range from looking at the effects of microgravity on the life cycle of mealworms, the biological nitrogen fixation process of microclovers, which is a well-known legume, and also the life cycle of a model organism for plants called A. thaliana. These experiments were designed by students ranging from grades 6 through 12, and it really demonstrates the use of the space station as a platform that engages and inspires the next generation of scientists, engineers, and explorers. Finally, we are launching hardware that are being pre-positioned for upcoming investigations, such as animal habitats for Rodent Research 6, gas bottles that will enable the advanced combustion in microgravity experiments, which is the next evolution of space combustion investigations, and resupply items for 3D printer manufacturing device, just to name a few. So these investigations are just a sample of the science that's enabled by tomorrow's Orbital ATK launch, and that continues to contribute to the advancement of human space exploration and to also improving the quality of our lives here on Earth. Thank you.
Thank you, Camille. Next, we have John Dickerson, who has more information, I believe, on that weather forecast everyone is watching so closely.
Yes,
He's the test director with Wallops Flight Facility.
Yes, good morning, everyone. Proud to say that Wallops is ready to support operations. Both our local sites and instrumentation is ready, and the downrange sites in Bermuda are ready. We completed our L-1 checks and CST tests this morning, so we are primarily green to start launch operations tomorrow. I have one slide. Could you please bring that slide up? This speaks earlier about the probability of violation, and those are the categories that we use to assess it. So we are green. We're less than 5% chance of breaking our having a violation. That goes for tomorrow, as well as Sunday.
Okay. Thank you, John. With that, we'll open up questions to those in the audience, on the phone line, and via social media using the hashtag AskNASA. If you have a question, please raise your hand, wait for the microphone. We have 2 mic handlers in the room. Wait for the microphone to reach you, and then we'll call on you. Just one moment, I'm sorry. Okay, we're good.
Jason Ryan for Spaceflight Insider, and this one goes to Kurt. Kurt, last fall-ish, you guys launched the OA5 mission with the RD-181. Was there any modifications to the Antares 230 that you made after noticing how that one left pad OA, or was it pretty much, this is what we're looking for, and we're going to move right on with OA8? Thank you.
Sure, thanks for the question. No changes to the flight design, the trajectory. There are a few tweaks in the minus count in terms of when we start some purges. We back some things up by 2 minutes just to give ourselves more time to get through some countdown steps, but that's really it. So they really were spot on. We fire each of the engines for a full flight duration and in a hot fire acceptance test, so we gain a lot of confidence in our ground testing, so that by the time we get to launch, we're very confident in the performance of the engines.
Great. Jason did this, but just a reminder, if you do have a question, make sure you identify to whom you're addressing the question, as well as waiting for the microphone. I think we have one here in the front.
Jeff Faust of Space News for Frank. Is the plan to fly out the rest of the CRS missions on the Antares from here? And what is the planning right now for the CRS-2 missions that you have under contract?
Yeah, so our baseline plan is to continue to fly Cygnus on Antares. We are ready to respond to our customers' needs if they should require something differently, but for all of the rest of CRS-1 and so far for the CRS-2 missions, we're planning to be on Antares.
We have a question in the second row. Sorry.
Hi, Ken Kramer for Universe Today, Northeast Astronomy Forum, for Dan and Frank, I think. Can you talk about why this stay of the Cygnus is relatively short? I was wondering, is it maybe related to the SpaceX? You have to get it out of the way. And Dan, can you talk a little bit more too about this commercial crew test that you're going to do with the Cygnus?
Sure.
After you detach it? Thanks.
Let's see, we do have some constraints on different vehicles on our Node 1 and Node 2 nadir berthing ports. I believe actually we're in a good configuration with Cygnus on Node 1 nadir, and then a SpaceX came up subsequently to Node 2 nadir. But in the configuration we're in, there's a lot of products that have to be turned over ahead of time. And so for the configuration that we're in with SpaceX, that analysis and all that work assumed the Cygnus would be gone at that time. And so that's primarily what's driving December 3rd. And we can do all of our, again, with a crew of 4 on the USOS side, that's not a constraint for unloading all the cargo, repacking the cargo, and getting the crews ready to go to release Cygnus and then perform this GPS test. And so what we plan to do there is maneuver, once we unberth, but still holding on to Cygnus, we plan to maneuver it to the top of Node 2 zenith, is what we call it, and hover it within about 2 feet of the actual berthing port. And what that's going to do is simulate a commercial crew vehicle that will be there. Again, commercial crew vehicles being there for a 6-month stay at a time. So then we plan to do, different variations with additional vehicles coming to the International Space Station. There was some concern we may have some, what we call our SIGI system, GPS blockage, while we have a vehicle up top there. We've ran some tests there before. It's shown good performance, so we're just trying to characterize it a little further. And Cygnus offers rather significantly sized module, and so we should get good blockage or good performance depending on how the test results show out. I think we're holding it there for 12 hours, and then the subsequent day, bring it back down to the nadir position, and then release. Cygnus will go fly off and do its actually height adjust and do its nanorack deploys. But that's the main intent. Again, to check out our ISS GPS performance with a vehicle there and another vehicle coming. That other vehicle coming needs to be in communication with us. So that's what we're really trying to check out.
Thank you. Our next question is from a NASA Social question.
Thanks. Okay, so Project Habu wants to know on Twitter, are there any personal effects from the astronauts' families aboard this flight, presents for the holidays, that type of thing?
That'd probably be a question for me, Camille. I don't know if you know. I can tell you, on every mission, we have crew care packages that we send up from family members. I could also tell you I think it's the first time we've flown what we're calling there's a brand name for it, but there's a long duration cold box, I'll say, where it has significant hold time to keep things cool, maybe 10 or 11 days worth. And we have packed that full of, I'll say, fresh vegetables, fresh fruits. So the crew's going to get some treats when they open up the hatch. So that'll be great for them.
Great. If you have a question in the room, please raise your hand and wait for the microphone to get there. We'll go ahead and take another question from the NASA Social.
So at Jack Squeeze wants to know, what does the T in T-10 stand for?
T stands for time, I believe.
Launch time.
Now, to further confuse the situation, we actually use an L clock and a T clock. So you may hear the launch conductor, Adam Lewis, talk about an L clock and a T clock. We run, the L clock is absolute, you start it, and it's going to get to 0 at 7:37, unless we reset it to go into the 5-minute window. But we will target the opening of the 5-minute window. That gives us the flexibility to delay up to 5 minutes, for whatever reason. There's a T clock that we run that has 2 built-in holds planned for about 10 minutes duration each. So the T clock will initially be in advance, and then we'll hit the holds, and then we'll slow down and sync up with the L clock at the end. So that's a little more information than anyone really needed to know, but if you hear L minus or T minus tomorrow on the countdown, that's what that's referring to. Test, you're too young.
We're actually going to take one question now on the phone line, and then we'll come back to the room. Go ahead.
Your line is open. Hi. I'm actually not sure which of you would be best equipped to answer this question, so I'm wondering, how many people on the U.S. East Coast will...
I heard 6 people.
Unfortunately, we're having a little difficulty with the phone line, so we'll go to a question in the room and see if we can figure out the phone and then come back to it.
Early in the morning as well. Will it kind of get in the way of seeing the rocket launch?
I don't believe we were able to copy on that question because of phone quality in the room. So we're going to go to a question in the room now, toward the back of the room, and we'll come back to the phone line once we figure that out.
Peter Coles, WSKB. For Frank or Dan, is there any significance that the launch slipped a day to Veterans Day and that the CERN will be launching on Veterans Day?
I should have mentioned that earlier. Our backup day is on Sunday, and so we have no constraints against that. Quite honestly, the vehicle traffic on the International Space Station is wide open for the next 10 to 11 days, I'd say. And I say that because we haven't probably looked out further than that. So Saturday, backup day on Sunday. If we happen to go to the Sunday, that would move our berthing date from Monday till Tuesday. And so that is just fine for our space station operations and our payloads that are inside Cygnus today. They can ride right on through that.
Yeah, I think the only thing I'll add is the original launch date I think you're referring to was November 10th. And, we moved it a day because it just works out from the orbital mechanics point of view that we actually get there faster launching a day later than if we launched on the 10th. It would have been, if we launched on the 10th, we would have got there on the 14th. By launching tomorrow, we actually get there on the 13th. So it was really for the science payload to get them from loading into Cygnus to the space station as quickly as possible.
We have a question again from Jason Ryan, and then we'll come back to the front row.
Jason Ryan with Spaceflight Insider. This one's for Frank this time. First question, Frank, is if there would need arose for a late-minute load, is there the capability at Pad OA to handle that? And the second one deals with Sapphire. You guys carried out 2 scientific experiments, Sapphire experiments, with Cygnus on prior missions. Is there anything planned for OA8 after it disembarks from the ISS? Thank you.
Yeah, so for the first question on the CRS-1 design that we have, we actually do all of our late load in the horizontal integration facility, and then we roll out to the pad. As we get closer, I think our final mission on CRS-1, and then as we get into CRS-2, we've modified the process in some of our designs to be able to load some late cargo at the pad. So that will be a capability that we'll roll out beginning on OA11. I think Sapphire, Dan, you want to?
Yes, our intent, in fact, it's our plan, is to continue on with Sapphire and at the start of the CRS-2 flights. So what is that, CRS-13?
0812.
Or 0812, yeah. And so we'll pick up Sapphire. They're actually making some lessons learned that they're applying to the next generation of that experiment. And so that will require some additional modifications inside the Cygnus, but our intent is to continue on with Sapphire operations. I want to say there's 3 planned in the CRS-2 time period. Mm-hmm.
Okay. We're going to go back to the phone line, and then we'll come back to the front.
Danica, your line is open. Please state your question once again. Hi, can you hear me this time? Yes, we can.
We can, yes. Thank
Okay,
you.
great. So my question is, I'm actually not really sure which of you would be best equipped to answer it, but I'm wondering how many people will be able to see the launch along the East Coast, and also how many people you're expecting at the Wallops Flight Facility Visitor Center to watch the launch. And then one last thing, with the sunrise happening around the same time in the morning, will that make it more difficult to see the launch?
I'll take a crack at it. This is Kurt. There will be a large number of people that will be able to view the launch. If you go to orbitalatk.com, and on there's an OA8 mission status page that our wonderful comms people have put up there for you. It's got all sorts of pictures and stuff. And on there's a viewing map that our ACE trajectory calculator, Carlos Dieterstrasser, does for each launch. It's kind of become famous. And on there, he lists at what time after liftoff, after the L0 time, you would expect to see the rocket break the horizon from where you are, based on where you are geographically around the launch site. And I do think that, yes, we'll be flying kind of into the sunrise, so it may make it a little harder to view it far down range. But near range, it should be plenty viewable.
Okay. Anyone else?
We have a question from Stephen.
We're going to take one more.
Hi,
we're going to take a question in the room, and then we'll go back to the.
Stephen Clark from Spaceflight Now. A couple of questions. First of all, maybe Frank or Kurt can give us an update on how things look for OA9. When do you plan that launch, and how's the hardware pipeline looking up for that? And also for Dan Hartman, have you made a decision on whether you'll use a reused booster for the SpaceX 13 mission in December? If so, can you walk us through that decision-making process, some of the certification you did for that? Thanks.
Okay, I'll start on the OA9 status. So the spacecraft is well along in its integration and test program at our facility in Dulles. It is actually just about complete with its test program, so that service module will be complete before the end of the year and ready to ship as soon as we need to support a launch as early as the first quarter of next year. The cargo module itself actually is shipped from our facility, our provider facility in Italy several months ago, and that's actually already in the H100 facility here at Wallops, and that's ready to go. And I think the rocket is undergoing integration in the horizontal integration facility.
That's right, and if those of you who took a tour or are about to take a tour, you'll see the OA9 vehicle in the horizontal integration facility out on the island. So it's in a pretty advanced state of testing and integration, and that'll finish up in the January, February timeframe.
Let's see, and SpaceX did ask us to, several, almost probably about a year ago, asked us to look at the reuse of a Falcon rocket. We're in the final stages of doing all those assessments. In fact, quite honestly, on the NASA side, we've had a lot of major reviews that we've talked through. But SpaceX themselves has one more readiness review for that booster before they'll commit to it being ready to go on SpaceX 13. I would imagine, although it's in the final decision, that if that comes back positive, I'd say the chances are we'll be flying a reuse on SpaceX 13.
Thank you. We're going to come back to the front row. Oh, I'm sorry. We're going to start. I'm kidding. We're going to go to the second row.
Hi, good morning. Jeremy Cox with the Daily Times and DelmarvaNow.com. I'd actually like to hear reaction from both NASA and Orbital ATK, if possible. So, Dan, Kurt, and Frank there, about the Edgar Zapata report that showed that the cost of providing these missions through commercial means is costing a half or a third as much, depending on the carrier, versus whether NASA had conducted the flights. Just kind of your thoughts on those findings, if you're aware of them.
Number one, I'm not aware of them, but I think it's just like a cost. It sounds like a cost evaluation of where we were to where we are. Well, I mean, that's quite honestly the whole rationale, reasoning behind the COTS program and the CRS program is to determine commercially if we can get a more viable and more affordable, I'll say, mass to orbit ratio of what we had been paying for in the past. I don't know what his numbers would say, so I don't have a good comparison on top of my head, but I mean, we're 5 CRS missions this year, another one to come with the SpaceX launch, and we're meeting the supply side of what we need on the International Space Station. And if you go back to the shuttle and what it was able to do and carry cargo, including all the assembly pieces for the space station, the ability to do EVAs, robotic operations, installation, assembly. There might be a little bit of apples to apples, but if you're looking at purely what we're trying to do as far as getting cargo to orbit, these CRS missions have been of great value to us.
Yeah, I'll just add, I thought the conclusions were awesome in that report. If you look at how we got here, it was the government and it was private industry co-investing in developing a capability to get cargo to the International Space Station on a commercial service type contract. And I think those numbers sort of bear out the success of that program. But I think even more than that, or in addition to that, we've continued to invest in the Cygnus spacecraft and the Antares rocket to be able to provide more to our customer in terms of science capability, cargo delivery capability, the ability to leave the station and then fly around after that to conduct all sorts of scientific experimentation. So I think it further bolsters the commercial model that there's a service there, NASA's paying us to provide a service. We provide more capability, and they continue to enjoy that increased capability. So I think it's a win-win all around.
Thank you. We are going to the front row this time.
Thank you. My name is Brian Meyer. I'm with the Orbital Social Group. I have a quick two-part question. The first one for Mr. Dickinson. What is the expected temperature at time of launch? And second, how far does the launch window extend time-wise tomorrow? Thank you.
Each window is approximately 5 minutes, and the temperature tomorrow, I believe they're reporting above 25, somewhere around there, 25 to 30.
How late in the day can you launch?
We have 5-minute windows. So they incrementally go back 5 minutes every hour or something like that, every launch attempt. I don't have those in front of me, but we have the clearances in place, approval in place from the FAA and our partners, external partners, to go out as far as the 21st.
Yeah, so if we wouldn't launch tomorrow, the next day we would launch 23 minutes earlier. And it's about that amount each day that you go.
Thank you. We have a question now in the back.
Hi, I'm Anna with NASA Social. My question is, how exactly do the ideas like who comes up with the ideas for what to do and what the launches will accomplish? Like, is there a room of engineers? Like where do the ideas originate? That's what I'm asking.
If that's in like relationship to what cargo we're flying on any given mission, that's kind of our side of it. Obviously, crew members are up there. They need food and water, supplies. We have spare parts, cargo, things break, and so we need some spares. Got a lot of complex hardware, such as EVA equipment that we need to always be replenishing. We demonstrate new technologies on board the International Space Station, so we're constantly flying those. And then we try to allocate and provide as much crew time on orbit and up mass as possible to have a vibrant research program on board the International Space Station. So there's priorities. People, different teams within our, the International Space Station program have their priorities. They're watching failures of their hardware. We have people that are tracking consumables. Those all kind of mold together. And quite honestly, when we talked about a little bit earlier, when you have 4 or 5 or 6 flights in a given year, you can then prioritize on risk or what really needs to go first. And we're willing to take some risk, I'll say, on the ISS system sides, if our payload community really has a lot of research gear that they want to get up there. Because our primary goal is to really utilize the International Space Station, and so and to keep our crew of 4 very busy all the time doing research. That's really proven out to be the case in the last 3 or 4 months. Almost on a weekly basis, we're breaking the weeks before record on the number of hours we've been allocating to our research community. So it's we kind of do it every mission. We look at the priorities and the needs, and at times we make decisions on let's move that hardware to the next flight and give that opportunity to the payload community. Pretty much how it goes.
And I can add to what Dan says from a research perspective. How we determine what we do up there is determined by our sponsors. So we have several sponsors of the research. The U.S. National Lab, through cases, they have a portfolio that they decide what's important to them. We have NASA-sponsored research, and that could be through the Science Mission Directorate, the Human Research Program, or the Space Technology Mission Directorate, and they decide what research is important to them. And then we have our international partners that also decide what's important to them from a national goal perspective. So that's how the research is racked and stacked.
Thank you, Camille. And we'll go to the back, and then we'll come back up to the front for an Ask NASA question.
Yeah, my name is Tim Green. I'm with the Anne Arundel County Public Schools EEE program from Park Elementary School. And in our program, we talk to our students about the process being important and looking at long-range planning. So my question was to NASA and whoever else might be able to answer this. What is the time frame for when NASA and their client first meet and start the process of discussing what they're going to do with the mission until launch day?
Yeah, in primarily from regards to a research, a payload kind of thing?
Yes.
Camille, you might want to take that one. I think you probably know that a little bit better. But
So it depends. For National Lab payloads cases, they can do anything as quick as, and Patrick, you could correct me if I'm wrong, as quick as 6 months to as far out as maybe a year or 2. But we start the research planning process maybe a year and a half out in terms of looking forward.
yeah, I kind of got your. If it's again from the educational side, if it's depending on the complexity, does it need power? Does it need communication links with the ground? Or if it's a simple rather payload, those can be done in months nowadays.
Mm-hmm.
And we again with the number of vehicles that we have flying, we could easily do something. I'd say from the time we approved it till we fly it could be on the order of 3 months, and we have done that in the past.
We have an Ask NASA question.
Yeah, we have 2 rocket questions. At Fight for Goodness wants to know how much horsepower the Antares rocket uses during launch. And then Jimmy Lynn, 1, wants to know with the 2 engines on Antares, can it still get to the space if one engine goes out?
I don't know the energy converted into horsepower, but it's roughly upwards of 700,000 pounds of thrust at liftoff, and we maintain that thrust level, and the rocket gets lighter as we consume fuel, so we get a little increase in acceleration as we go along. And what was the second question?
What if one of the engines goes out?
Oh, we do not have an engine out capability, so that would be an end of mission.
Thank you. Jeff Faust in the front row.
Jeff Faust, Space News. For Kurt, what progress has Orbital ATK made in identifying other customers for Antares, whether they be civil or commercial?
I'm not going to go into specifics. That's proprietary in terms of the bids we provide, but we are interacting with the civil government and commercial markets, and we are offering Antares.
Thank you. We have another question from Ken Kramer.
Hi, Ken Kramer, thanks. Kurt, quick question for you. You said the criteria was 20 degrees. What are your primary concerns starting at 20 and below? And for Camille, can you talk a little bit more about the Rodent Research 6? Are you bringing up gear or the actual habitat? Thanks.
Well, first of all, with regard to the temperature situation, there's three main cavities of the rocket. There's the fairing, and then there's a space between the two tanks on the first stage, and then there's the aft bay. Those three volumes are conditioned with our pad air conditioning system that provides heated or cooled air and humidity control. So we pump a lot of air into those volumes, and that keeps all the components in there nice and conditioned, including Cygnus, including the second stage solid rocket motor, batteries, ordnance, RF gear, anything that could be a worry in terms of temperature. Now, there are some separating joints on the fairing that are also exposed to the exterior surface of the rocket, and so those do get exposed to some cold temperatures. But we've done a lot of analysis and test on those joints. One side will be warm, the outside would be cooler. We fired it down to very low temperatures, and we have a lot of margin baked into that 20-degree Fahrenheit constraint.
Thank you.
And what we are sending up is what is called the animal exposure module, and that's actually the habitat that the animals will live in once they come up, but they're not coming up on this flight. But that's a pre-positioned hardware to get ready for them to come up on the next flight.
I have a question in the front row.
Thank you. My name is Winston Campbell. I'm a social media guest here today. Question for Orbital about the Cygnus vehicle. You've named this after Gene Cernan, and I was wondering if your plans for the vehicle itself are to recover it and return it to service, or do you have some other intention for it after the mission?
Well, so once we complete the primary mission, which is delivery to the cargo, we'll fly away and we'll deploy our CubeSats. Actually, we'll do the GPS blocking experiment for the space station, and then we'll fly away and deploy the CubeSats, and then we'll end the mission by destructively re-entering over the Pacific Ocean. Cygnus is designed to maximize the amount of cargo we can deliver, and so there's an exchange there of whether you would like to re-enter something or which takes a lot of mass to do. We've converted that mass into cargo mass, and so that's the focus of the Cygnus capability.
Thank you. We'll take an Ask NASA question, and we have time for one more question in the room.
So a number of people on Facebook want to know what's being done to keep boats out of the range area.
Yeah.
So the effort starts months in advance. We've got a great guy by the name of Jordan West. He reaches out to the public. We have, I think, 4 or 5 surface vessels positioned strategically throughout the hazard pattern. We have our fixed-wing aircraft doing airborne surveillance, and we have one helo that's going to be doing the back bay. So we'll start up with our surveillance activities very early in the count, and we'll be talking to them as much as possible. I like to say that we've gotten a lot of help from the local fishermen to tell everybody, hey, this is a 5-minute window. We only need you to stay out for 5 minutes. So we keep our fingers crossed. So.
We will keep our fingers crossed. Do we have another question in the room? One question.
Hi, I'm Tracy Glock from NASA Social and Paramus Public Schools. What words of wisdom could you offer for students that are looking to pursue a career in aerospace or aeronautics?
Dream big. No, I'll tell you, I'm sure everybody up here, you kind of look back on the careers we've had and the excitement that space brings you. It's pretty amazing. And you can take that next step and, they could dream to be in the astronaut side of this thing as well. But I can tell you, it is so fulfilling, and you feel so proud of what you're accomplishing. The International Space Station is just a miraculous vehicle with multiple nations coming together for peaceful purposes to, benefit folks on Earth. And, we've been able to keep the thing operating continuously with humans on board for the last 17 years. So it took a lot of teamwork, it took a lot of working through issues. It brought on new capabilities all the time. And so it's quite honestly, it's just amazing the pride that you feel being part of the program. And I would just tell the young students to keep striving for that and try to find that niche and be happy with what you're doing. It's just been awesome.
I just to add to what Dan said, I think it starts with us, the big us, and exposing the kids in the schools to what we have the pleasure of doing in our careers. What we do is amazing from our internal, how we feel about it. It's a special thing we get to do, and so to expose the kids to that and to relay that feeling, I think is important. I think now, more than ever before, we actually giving access to space to students, and we have experiments flying up on the spacecraft tomorrow. That's really special, and so we've got to foster that excitement and make sure they understand that there is no limit to what they can do, and I think that's very important.
And a plug for the girls: don't be afraid of science, don't be afraid of math, and just dive in there, and you can do it.
Excellent.
Okay, nice. Thank you for the question. Thank all of our presenters for joining us, and thank you for joining us on this Veterans Day. A reminder that NASA television coverage will begin at 7 a.m. Eastern Standard Time Saturday for the launch. You can watch that on NASA television and on the agency's website, which is www.nasa.gov/live. Thank you.